So we're going to look at this problem. We're going to look at something called rational indices. So rational indices are when you see a fraction, when your index is a fraction. Bear in mind, the rules are the same. We're going to use the power rule with every single index within the parentheses. So it's going to go with the 100. We've got 100 to the 1/2. X to the 16 over 2 over, that's an 8 by the way, y to the 8 over 2. And now we can simplify. 100 to the 1/2, that just means the square root of 100. That just means this. Okay, and then x to the 16 halves, we're just going to simplify 16 halves to be x to the 8. And this is y to the 4. Are we finished? No. Whenever you see an operation left undone, you have to do that operation. In this instance, the operation is finding the square root of a number. Square root of 100 is 10. X to the 8 over y to the 4. There's the solution. Okay, here's another one. Now I want you to do yourselves a favor. Please pause this and try it on your own. Remember, simplify within first and then worry about the index and use the power rule to solve it. And don't forget, with the 27, the index is a 1 because it's a whole number. So please pause it now and solve it, and then press play to see if you got it correct. Press pause. Make sure you solve it before you press play. I know what you're trying to do. Pause it. Solve it on your own, please. You're so busted, I caught you. But hopefully you tried it by now. And now I'm going to show you how to do it. And what's nice is there are absolutely no consequences if you got it completely wrong. So I'm going to simplify it within, and I'm going to, 27. If I'm solving it within, then the 27 is unaffected because there are no other numbers in there. The x is unaffected, so x to the 12. Well, the y, here, the y to the 8, I leave. The y to the negative 1 comes up. I find the inverse. And we have a denominator, it's 1, but we don't really have to worry about it. But I'm going to write it to make it a little less confusing. And this is all to the 1/3 power still. I'm going to simplify within, I should say. And when we multiply indices with the same base, we just add them. So 8 plus 1 is 9, x to the 12, 27. And that's to the 1/3 power. Okay, so 27 to the 1/3, x to the 12. Again, we're multiplying now. We're doing 12 over 1 times 1/3, and we get 12/3. And we get y, 9 over 1 times 1/3 is 9/3. One more step. This is the third root. If it's to the 1/3 power, it means to the third root. What times itself is 27? Well, that's 3. 12 divided by 3 is 4. 9 divided by 3 is 3. We're finished. And here's our next one. And we've got a scenario now that we haven't seen yet. And we have a negative exponent, only it's not with a variable, it's a number. But bear in mind that variables are just numbers, but we don't know what the numbers are, so they're represented by letters. So the rules are going to be the same. Press pause, give it a try, then press play, see if you got it right. Okay, here we go. So I'm going to solve this. I'm going to simplify within, and I'm going to move, remember, any whole number that doesn't have a power, it's 1. So I've got a 27. I'm going to go ahead and draw the line here. I'm going to move the 3 to the negative 1 up to be 3 to the 1. I'm just not going to write the 1 because we don't need it. A to the 6 divided by a to the 2. We subtract when the bases are the same, so that's a to the 4. Nothing on the bottom. I'm just going to write 1. And I'm going to keep simplifying within. 27 times 3. Here we go. 81. A to the 4. And we can write this 1 as a denominator. We don't have to. To the negative 1/4. Okay? Now there's a problem. Well, actually, before we confront the problem, let's go ahead and use the power rule. So we're going to multiply these all by negative 1/4. Negative 1/4. Now we've got a to the, remember that's 4 over 1. So we've got a to the negative 4 over 4. And that's all over 1. And now we have to find, sorry, it kind of got blurry. That's what I get for buying an Asus. I'm going to move this down and make a positive, move that down and make a positive, down to the denominator. So I have 1 over 81 to the 1/4, which is the 4th root of 81, and a to the positive 4/4, which I'm just going to call it a to the 1, because 4 divided by 4 is 1. Now the 4th root of 81, we're almost done, hang in there, is 3. A, and we are finished. Look at all that work we did. Beautiful, beautiful. All right, I want you to try these 4 problems on your own. So please press pause and try these on your own. And then press play to see if you got them correct. So for number 1, if I reduce or simplify 16 over 64, that simplifies to 1/4. And you're going to do 8 minus 4, so 8 to the 4th in the denominator. And now I'm going to find the square root of 4 and the square root of a, and there's the solution for number 1. There's number 2. Not entirely, but I simplified within. And there's a solution for number 2. This is a 3. It looks kind of like the form 9. Let me fix that. There we go. Somewhat easier to see. Okay, number 3. So I've got this. I'm simplifying within. Now the power rule. Now I've got to find the inverse of both of these. Bear in mind there's a 1 down here. So I'm going to move them both to the denominator and make the index a positive. And there's the final solution for number 3. Number 4, this is the scenario we looked at when I showed you the final example problem. I'm going to go ahead and solve it. Hopefully you've already done it. Okay, I found the inverse of the negative indices. Here's the next step. And the final step, one last final touch. And we're finished. Nice job. Look at all that work we did. But it is rewarding at the end when you find the correct answer, isn't it?